I'm, as I mentioned before, Clemens Neudecker. I work at the National Library of the Netherlands, and I'm also the technical manager for the Impact project. So, actually you look pretty much awake. I've been thinking about how to actually wake people up. I thought of some quizzes, like does anyone remember how many petabytes would the British Library digital collection roughly be if it's fully digitized? 50, that's correct. And how many zeros is a petabyte? 15, okay, thank you. So glad to have you all back. Actually missing a slide here, but no matter. So yeah, I'm going to talk about the Interoperability Framework, what it is, why we built it, and what you can do with it also. So you've already heard from Hillary's that we have really done improvements in many different areas of work in the Impact project. And of course, people from very different backgrounds, commercial developers, research partners, people within libraries, etc. So it's a very broad mix of frameworks that have been used and solutions that have been implemented. And also we see like some of this stuff, it's really brand new. So there have been papers which have been written in the project, which have just been put into code. And on the other hand, we have this stuff like very mature products like, for example, Fine Reader. And so we wanted to join these. We wanted to have a platform where we can couple these tools, put them together and see how they work with each other. We also wanted to be flexible enough to incorporate, not for testing only, but also maybe for production or other possibilities, external tools that are either available as open source or available to us. We've heard by Paul Vogel, for example, Google is using the Tesseract engine, which is available for open source. There are also a number of other interesting open source tools in this area. So what we did is, rather than package all this impact stuff into one solution, really one package integrated, we thought we'd keep them separate as individual modules, but we would, on top of that, build a framework which allows us to connect them and exchange data between them. That's much more flexible than having just a black box, image out, text in, image in, text out. So for the techies, that's the architecture, what we've been using. We've have main Java as the main layer for the interoperability. We use web services for the tools to communicate between each others. And then a number of things from the Apache Software Foundation, a really active community of open source tools. And it's all pretty standard. So people who have been working with this stuff, they should be familiar with these. The whole components that we have developed for this are really available as open source. And there's a link which I see it doesn't really display very well here. So there is a GitHub repository. It's, if you cannot read it, it's github.com/impactcenter, one word. And we have been releasing a couple of, now I must say, caveat, still better versions of some of these tools there. We're still working on them, improving them, implementing new features, fixing bugs, etc. More will also be released during the upcoming next months. We're also hosting a free hackathon around these tools. So that's 14 and 15 November at the University of Manchester. It's mostly for developers who work or are somehow related to cultural heritage digitization and want to try out these tools, see how we've applied them, learn how to use them within their own projects. And so, yeah, it's free, and we still have like, about 5, a bit more open places. So there's also an address. It's too long, actually, I would not read it out to you, but you can find it also on our homepage. So how does the thing work? Basically, we only have one requirement for integrating all kinds of various tools within the platform. which is really simple because we wanted to have an all-embracing solution. It should be able to be executed on a command line. So that's it. Ideally, it should come with some parameters also that would tell us like what kind of functionality is available from the tool and what you can do with it, how you can refine it. But if it runs on a command line, we can actually make it, plug it in. What we then do is we use this command line, and we have created a wrapper tool that's also on this GitHub repository. And that just very easily allows you to create a web service from any command line tool. And this web service, that's our interoperability layer, on which all the tools interchange data between them. But we also added another layer on top, which we call, or which is called a workflow layer. And that's basically what you see on the lower right, and it's just a different representation of a tool with documented inputs and outputs. And you will see in a minute what benefit we have from that. So I just want to say, it's from our experience, it's been proven quite effective in terms of integration, because it's really, if we have a command line tool, we can get it integrated, plugged in, and interact with the other systems, usually within minutes. So no big requirements for the tool providers to actually tune their stuff in order to fit in some very tight frame, but they could really focus on improving their applications. So yeah, workflows. Why workflows? So we've already seen that in a number of presentations. Hillary's had it. Also, Klaus gave an example of the DocWorks workflow. Typically, what you see on the left, OCR, the full process, once you have a scanned image, is always a data flow. So you go from some image which comes from the scanner, apply some image enhancement, binarization, etc., segmentation, and so on. And usually it's one sequential flow of data. So this can be quite nicely modeled into such workflows. So what you see to the right, these blocks, I'm afraid you cannot read it probably, but believe me, so each of these blocks, individual blocks, is an impact tool, which we have there with its documented inputs, outputs. And so there is a user interface for that I will show you in a minute, and it allows you really easy, just by drag and dropping, actually, to then combine them into a sequential data flow like this. So within seconds, you can try out different combinations of tools, different variations, and we'll see what is the benefit of that. This has been done also in collaboration with MyGrid. That's a project funded by the OMII in the UK, and we're also jointly organizing this hackathon with them in November. So this is an example of one of the impact workflows. So these things can get rather complex. Just to explain, like on the top we have an ingest, which just gives us a number of ground truth files from our database and also the corresponding images. And then we run these through 3 different OCR engines. That's on the left, the Abby FineReader 10. In the middle we have FineReader 9, the state-of-the-art before the project, and then Tesseract to the right. So you can also nicely parallelize things within the system. And then on the lower level, we just compare each time the output of the OCR engine with the ground truth text to see how well they perform. So you can model your workflows like this around all kinds of challenges, research, investigations that you want to do, and starting from the resources that Impact provides, really get quick results. Yeah, so one thing that has been proven most interesting within Impact is really to evaluate these different combinations of tools. And Stefan, who is the next speaker, he will say more about the evaluation capacities and the features that we have there, also about the ground truth. But so we have basically three tools for evaluation implemented within that framework. That's just a plain text evaluation, also based on the Levenstein distance method that Klaus already explained in his talk. We can do a word evaluation, which also considers reading order. That's really quite important. So, for example, if segmentation goes wrong and you merge 2 columns, you destroy the reading order. That's not really important if you only do word search, but if you want to do more sophisticated scenarios, that's quite a stopper. And we also have, and there we really benefit from this rich ground truth that has produced in the project, layout and segmentation evaluation based on the page format, and that is also going to be explained later by Stefan. So the idea is that using these workflow modules, you can very easily plug them together. And I don't know if one can read it, it's not very sharp here. So what you see on the bottom is the left workflow. It just uses document images and ground truth, runs an OCR engine on the images, and compares the text with the ground truth. The one in the middle just adds a small pre-processing step, which in this case is the warping, so straightening of text lines. And adding this simple module, you can transparently evaluate each of the individual components and see whether they really contribute to the overall accuracy. The nice thing is that this whole workflow system, it comes with a number of features that are just perfect for the way we want to use them within Impact. So there is a Web2O style registry, My Experiment. You can go there online. And this is a research environment where you can upload these workflow modules and share them with others. Other people can access them there, run them from there, comment them. You can rate them. If you're not happy, give them like a bad note and a bad mark and see whether someone picks up on that. So it's really nice because you can have their access to the actual tools and data in one environment, which also allows people to exchange their ideas about this. We apply these workflows to impact material in the scope of the project, mostly using this tool, which is provided by MyGrid. It's called Taverna, and it's quite a nice tool for our purposes, whereas it comes actually from a totally different background, the biosciences. But when we evaluated the solutions that were available for this, we saw that this is actually very well fitting to the demands of an OCR workflow. So they also want to process huge amounts of data, like genome analysis, for example, with a distributed set of tools that have been developed amongst different research groups. And so it's quite actively used in this domain, whereas it's really domain independent. So there are also some examples of use in other domains. It's completely open source and available for all different platforms, so happy to get it and try it out. And it comes with a graphical user interface, as you can see. So rather than wasting efforts on implementing yet another user interface, we could just adopt that. And you can see here, you can run the workflows within the system. You can design them, rearrange them, play around with them, and then see the results also there. But another thing that we did, and that was for us to demonstrate that this is possible, but it also turned out to be quite useful if you don't have the option to install software, for example, on your computer. Actually, some libraries are quite restricted with what they would allow their employees actually to use. We also implemented the system with our website. So without having to install anything on your local computer, you can just go to our website. It also relies on these web services, so there is an API for it. And on this site, when you're logged in, I must say, you can just try out these tools, and it will create for you dynamically an HTML form, and you just fill in the inputs, run it, and it will then show you the results also on the web page. So you don't need to play around anything on your local computer, don't need to change anything on your computer, just run it through the web. Another thing that we built, especially for Impact, that will also become available via GitHub is a custom service that would allow the libraries in Impact to store their results from their testing in a consistent way. So what we did, we just built another web service for that, actually, which was custom crafted for Impact, but it turns out might actually also be quite useful in other areas. And we built that using, again, for the techies, they might want to know about it. It's WebDAV using WebDAV protocol, so that's very easy. It's something which is basically relying on HTTP. and anyone can use it who can use a browser and go to the internet with that. So that's really very interoperable. So with the system, we can store these results of these test runs. We can configure them, like what we want to store, how we want to store it, and where. And we can also create some basic reports from that, just to get like aggregated results and some visual display. Another central point, we've already heard about that also from Paul Vogel, amazing numbers, is really that mass digitization is now happening on the scale of millions of pages and petabytes, not terabytes even, but petabytes soon. So we had to somehow adapt the system to make it also able to serve these demands on a large scale. And so what we did is basically for testing, we just rolled out this software stack with 5 different partners in the Impact project, 5 different libraries, which gave us an indication, first of all, does it really work in their different IT environments? And then we just add another small server on top, which then acts like a kind of a load balancer and distributes this load amongst the available servers. So this allows us to scale it up, to parallelize the process on several instances, and thereby speed it up. And also, if one of the servers crashes, there are still a number of others which can then handle the request. So far, actually, in the Impact project, we've served a bit more than 2 million requests using the system. And we've done some smaller scale tests to see how well does it scale up with adding additional instances, and actually it does very well. So we see only like about bit more than 5% overhead from these interoperability layer which we put around the tools. So that's not too much actually if you think we're working with large images here. However, this is a distributed system which is hosted throughout Europe, so there's a drawback in having to transfer data through the internet, which is sometimes still not as quick as you would wish it was. And so what we're aiming for to sustain this is to just have it in one like cloud-based environment, and we've tested that successfully with the Dutch supercomputing cloud. So that is also possible. That's going quickly. To give a bit of an outlook, like as it said, work for OCR and beyond, what can you do with it? So Impact explored this as a service just for processing, for testing tools, running different kinds of evaluations, and really see, that is, I think, quite important from talks we've seen so far. There is not the optimal solution which will just perfectly OCR all your millions of pages, but there is really much to be gained if you fine-tune your workflow slightly. We've seen in the talk from Apostolos, there are really huge differences by applying different methods to different source material. And if you have a system that gives you this flexibility, plus the scalability, I think personally it's always worth the investment to just look a bit more into the material that we want to process and then really tailor your solution to that. So this is the use and impact. There will be a specification and guidelines are still going to be released also, but we've already seen, and we're quite happy about that, some take-up in other communities. So, for example, Clarion is something we will hear about tomorrow. It's also a large European effort to work on linguistic analysis of texts. And recently, a new project in this library domain that started, Scape. It's about preservation and scaling up preservation. And there we also see that they're using a number of impact tools for this, and also, which we're very glad for, further helping to improve them and also sustain them after the project has ended. So one of the things that they will likely work on and want to implement is MapReduce. So that's a method for really scalable parallelization of data that has been originally drafted by Google. So you see there's a system which you can just grab for free and use it, and there is a community already forming around this of not only developers but also practitioners. So we're very keen on really working on this to satisfy the requirements of the content holders. That's really important, like not to build a system for techies, from techies for techies, but something that really everyone can apply. And I think these workflows, they're quite easy to use. So before I wrap up, I just wanted to show you something. Actually, that was I thought that was going to be at the beginning of my slides. So this is related to what Paul Vogel said with this Mongolian text. So if you have large-scale data, you will also probably find things like this in your workflows, and probably most of the OCR would fail on this. So for those who haven't seen it, it's the widely known as the most oldest printed book in the world, and it's here at the British Library. It's the Diamond Sutra. It's from the 9th century, and unfortunately, I've just been told you cannot really visit it, the physical copy. It's safely stored away, but they have a very nice website with a page turner where you can have a look at it. And actually, just one more thing also to wrap up, because my personal background is actually with humanities. So I studied philosophy of language, and just recently I went to a conference where we've been working with people from digital humanities, and they are really keen on having better OCR. Actually, they don't want 90%, they really want 100% because they want to do text comparisons. So we've seen a lot of stats and bars, and you will see more about improvements and impact. But what here Ludwig Wittgenstein, famous language philosopher, said, actually quoting Nestroy, is anyway, the thing about progress is that it always appears greater than it really is. So what I want to say with that is I don't want to negotiate the work that has been in impact, which I think is tremendous, but it's just the beginning. So once we have these texts available, working with them, really looking into this material and all the possibilities that are enabled through full text search, that will be the next step. So, and that's it. Thank you. So I wonder how we're doing on time. Yeah, there's time. If there are questions now, I'm happy to take them. Usually the chair is supposed to come up with a question, but I'm the chair myself, so it would be nice if someone helped out. Otherwise...
Have you looked for Wittgenstein yourself, Clemens? Have you looked for Wittgenstein? Have you searched him? On the net?
Yes, I did. And the nice thing is there is an electronic edition of Wittgenstein, especially of his estate, which is really quite interesting in this particular case. But again, we have the issue that actually the transcription is prone of errors. So maybe crowdsourcing, post-correction, which we'll hear about, will be a possibility to use in that area. I would hope so.